So, good morning everyone. So, today I will discuss uh, about foundation engineering, starting with chapter 1. So, chapter 1 is about the general view, or let's say the foundation structures, generally in terms of its definition, their types, and some empirical formula. So, chapter 1. So, we have here essential environmental consideration of a good foundation. So what is the requirement? What are the requirements of a good foundation? The first thing is the foundation should sustain the dead and imposed load and transmit this to the subsoil such a way that pressure on it will not cause settlement, which would impair the stability of the building or adjoining structures. Remember that buildings carries different types of load, and the major loads that I'm talking about is the dead and the live load. Okay? Of course, we have also earthquake load and wind load. Okay? So uh, these four are used to load on the building, and you will come up with a suitable section that will carry the load. So again, the foundation should have the ability to sustain, or should have the ability to carry whatever loads it will have and transmit this to the subsoil, because remember the basic process of structural analysis is that if you have loads, the loads will be directed on the slab, and the beam will carry the weight carried by the slab. Then the beam goes the transmit to the load to the column, then column to the foundation, and to the soil. Okay? So, this pressure should not cause settlement. Meaning, you should have suitable section that will carry the load, and also the soil beneath the foundation should not cause settlement, because settlement would impair the stability. Okay? Stability in a manner that uh, there will be some uh, structural effects on the structure, because once there is uh, disability of the foundation, it will affect the column, the beam, and the slab, and of course the total structure. Then the second one is the base of the foundation should be rigid, meaning rigid means it has the ability to resist deformation so that differential settlement are minimized. We cannot really uh, avoid settlement, but we can minimize if we have a proper or suitable foundation, especially for case when superimposed load are not evenly distributed. Then next one is foundation should be taken sufficiently deep to guard the building against damage or distress caused by swelling shrinkage of the subsoil. According to the some textbook that I read, uh, the depth of the foundation should be around one-third to one-fourth the height of the structure. Okay? The depth of the foundation uh, is very critical, because it will add it will add uh, structural soundness on part of the structure if you have enough depth. Okay? Basically, if we consider a building that is not properly that is not properly uh, put or not properly in a correct depth, okay, and there will be, let's say, earthquake, the tendency is it does not have sufficient force from the soil to avoid some movement. Because if you have sufficient deep, or let's say sufficient depth, the soil beneath of it will help also the foundation to sustain or to help the structure and to minimize the settlement if there will be some earthquake load, or yeah, or other loads that will act on the building. Then foundation should be so located that its performance may not be affected due to unexpected future influence, meaning this is regards about the site location. Okay, for example, it will be difficult for us if the location of the foundation of the building is, let's say, sandy. Let's say the location is what do you call this one, is watery. Of course, in the future, uh, there might be some unexpected uh, failure that will affect the performance of the foundation. Okay, that's why uh, for the foundation, it is necessary that you need to conduct soil exploration, especially uh, if you are considering 3-story and up. You need to conduct soil exploration to determine whether uh, the the soil is capable to carry the foundation, and also the bearing capacity is high. Okay, because remember, if the bearing capacity is low, you need to come up with very large size of foundation. Foundation should be such that it can easily carry dead load and imposed load of the structure and transfer load of the soil. Same with what we have discussed in the first characteristic. Then foundation base should be strong enough to reduce the unequal settlement of the soil if imposed load is not distributed equally to the soil. So sometimes when you are putting up a building, the loads may not be the same from one point to another point. Okay? Because remember, for a building, uh, the loads may vary depending on the purpose. For example, if you have a commercial building, okay, the loads of commercial building may not be the same to, I mean, commercial space may not be the same to the landing, may not be the same to corridor, may not be the same to balcony, because different location has its own equivalent load based on NSCP. Then it should have a definite depth so that the structure may not be damaged due to the expansion or compression of soil volume beneath the foundation. Foundation should be strong and designed with safety factor so that the structure may not be damaged due to unexpected effects. So in this figure, we have here the typical isolated. Okay, so you have here the foundation, then you have the column. So 5 essentials for good foundation wall. So we are talking about the basic one. So the foundation wall of your home comprises a critical component of the structural support system which carries load from the floors and walls above the footings below. Foundations are overwhelmingly made from concrete but can also be constructed with masonry, especially treated wood and other materials. By the way, class, foundations are not always it's not always concrete. It can be made of wood. Okay? In before, but now the most common na I no, not the most common, but the foundation is really made of concrete. So in addition to transferring weight, properly designed foundation also serve to keep moisture away from the home. So before beginning construction of the foundation wall, rough grading on the site should already be complete, and excavation if required should also be complete. Lastly, footings, if not simply pouring slab, should have been previously poured and sealed. With that set in order, so we have here the 5 essential for constructing good foundation wall. So account for the site condition. So you need to test and you need to understand the properties and soil condition of your site. Okay. Then select the right style. Many foundation types are determined by the site condition, but it can also reflect regional references as well. 3 varieties of foundation are commonly used: full basement, crawl space, crawl spaces, slab on grade. Of course, it depends on the on the site condition. Then plan for moisture control. By the way, I'm talking about the general essential, not only in the Philippines, but of course, it will be applicable to other countries also. So keeping subsurface water away from the home foundation. This is also important. Okay? You need to put some waterproofing to avoid some moisture that will affect the integrity of the concrete. Then know the pitfalls. Understand the crack. Small vertical cracks are seldom problematic unless the width is not consistent from top to bottom. This indicate uneven settling of the underlying footing. Horizontal crack is bad news and is indicative of complete failure of the foundation wall structure integrity. So you should check that one, that during the construction, you check whether there are some cracks, because cracks are indications that there are some structural implication that there might be some problem. Okay? Then the last one, follow this step. Consider insulating under the slab. Meaning, we are talking about slab on fill. Meaning, you need to insulate. Okay, if we are considering, let's say, mat foundation, because it's pure slab, you need to put lean concrete. Then ensure proper base material are used as specified, that they are compacted properly prior to pouring of the footing. This is also important. Okay? Be sure that the base of the footing is properly compacted. If not, you need to put some maybe coarse aggregates, or if not, lean concrete before you put the reinforcement. Then to save cost, use a more square foundation type instead of following every jog in the home's footprint. Use cantilevered construction technique above grades for jog like by window. Then pour the foundation in one continuous pour to bind the entire structure. This is very critical for all types of structure. We should assure that when we are pouring concrete, it should be in one setting only, so that we achieve homogeneity, means one property of the structure. Then allow the concrete to cure properly. Okay? So, yeah. Curing is allowing the concrete to uh, gain the required strength. Okay? So we have kinds of foundation. So again, foundations are structural components used to support columns and transfer loads to the underlying soil. The function of any foundation is to safely sustain and transmit to the ground on which it rests the combined dead, impulse, and wind load in such a manner as not to cause any settlement or other movement which would impair the stability or cause damage to any part of the building. So if you look at it, that is the scenario. It's always like that. Loads are always transferred from top to bottom and going to the soil. Okay? So for foundations, we have two types, the shallow and the deep. Shallow, strip isolated, combined, strap, mat. Then deep is basement, buoyancy wrap, caisson, cylinder shaft, pile. Nowadays, some of it are not really use, okay, especially in the deep foundation. The most common one here is, of course, the pile foundation. Then we have also the basement foundation. But I don't know for these three, if I'm talking about in my experience. Then for foundation, yeah, strip. This is actually, strip is also called continuous footing. This is for the footing of the wall. Then isolated, it can be square, rectangular. Then combined, it can be square or rectangle. Then strap or cantilever footing is similar to combine, but it's less in cost. Okay? When we talk about cantilever. Because in cantilever is, you will combine two adjacent isolated footing with a single beam. Okay? So, it's like combined, but you reduce the section of the combined footing. Then mat is actually the what do you call this one? The pouring in one setting means if the area of the structure is 10 by 10, the foundation also is 10 by 10. Okay? So, shallow foundation used for transferring buildings load to underlying ground, mostly for firm soil or light loads. This is a type of foundation which transfer building loads to the earth very near the surface. So in this diagram, we can see here the typical example. So if it is firm, meaning you have only, sorry, you have only uh minimal depth. Okay, but for depth foundation, this foundation are too deep below the finished ground surface. Sometimes the depth is more than 3 meters. Here, if, for example, you have a multi-story building, and of course, the soil is weak, you cannot just follow the same scenario for shallow because this is weak. There is a tendency that this will topple down. So you need to what? You need to locate where is the bedrock so that you are confident enough that the structures are lying on a hard part of the soil. Okay? So this is necessary if you have if the structure is lying on very weak soil. Okay? So strip foundation footing is provided for load-bearing wall. A strip footing is known as continuous. So this is usually for hollow blocks. So this is the footing and this is the hollow blocks. It is continuous. Okay, because most of the time the length is continuous. Okay, and also when you design this one, we will assume only 1 meter width. Okay, because 1 meter, and we assume continuous, so we need to get a sample in designing. Then isolator or pad footing is provided to support an individual column. Okay, sorry for this one, this is wrong. Sorry. This is provided to support an individual column only. This one. Column footing, column footing. Then combine supports two column. It is used when the two columns are so close to each other that their individual footings would overlap. So, for example, if you have two adjacent column, and for example, the distance between the two is 4, for example, and this column, based on your calculation, the required size is 2.5 by 2.5. This one is also 2.5, 2.5. So if this is, sorry, let's say the distance between the two column is 4, and based on the calculation, the size of this footing for this column is 5 by 5. This one also 5 by 5. So 5 divided by 2 is 2.5. 5 divided by 2 is 2.5. The column now already overlap because the distance between the two, if we consider the design of the footing, is 5 meters. But the distance of these two is 4. So you need to combine it. Okay? So it can be rectangular or trapezoidal in plan. So when this trapezoidal putting happen, it happens only when there is an equal distribution of load. So for example, if you have two adjacent and the load carried by this column is very large compared with this one, of course, it needs large section and smaller compared with this one, and they overlap, so you need to combine, but the section is trapezoidal. Then strap footing. It consists of two isolated footing connected with a structural strap or a lever. The strap connects the two footings such that they behave as one unit. The strap is designed as a rigid beam. This is a similar to combined footing, but look at it. We remove some section here. This is like value engineering. So a strap footing is more economical than a combined footing when the allowable pressure is relatively high and the distance between the column is large. Meaning, uh, this is more economical and the allowable pressure is high but the distance is large. So, if you put up combined between the two, it may be costly. So, you need to provide a beam that will connect the two. Sorry? Sorry. What happened? Sorry, class. So, we have here, yeah, mat or foundation. This is a large slab supporting number of column wall under the entire structure or a large part of the structure. A mat is required when the allowable soil pressure is low or where the columns and walls are so close that individual footings would overlap. So this is similar to combine wherein each ad, each adjacent column overlap. So every adjacent overlapping each other, you need to put a mat foundation. And also, if the soil pressure is very low, that is necessary. So we have deep foundation. The first type of deep foundation is basement foundation. These are hollow substructure designed to provide working or storage space below the ground level. The structural design is governed by their functional requirements rather than from consideration of the most efficient method of resisting external earth and hydrostatic pressure. So for example, if we consider some big structure, for example, for SM, huh? No, sorry. For what? Uh, Maybe hotel. Let's say hotel. Most of the hotel, of course, it consists of multi-story. You expect that the depth is very deep. And of course, because of that, okay, some engineers use the space. Okay? It can be for storage, for parking, and so on and so forth. Okay? Because uh, the depth of the depth of the column is very large because you need to satisfy the required depth based on the height. So this is very applicable to a very high-rise building. Then buoyancy raft. These are hollow substructure designed to provide a buoyant or semi-buoyant structure beneath which the net loading in the soil is reduced to desired low intensity. So we have here, unlike the basement, you enclose this one, and this way this one will reduce as your buoyant structure that will help the structure to avoid settlement. Okay? Basement introduced to reduce the effective ground pressure due to the building weight. Okay? Then caisson are hollow substructure designed to be constructed on or near the surface then sunk as a single unit to the required level. Then pile foundation. Pile foundation is a form of foundation using piles to transfer the loads of a structure down to a firm soil stratum with sufficient load-taking capacity. See this one? High rise, then weak soil, you need to touch the bedrock. So pile foundation are structural members that are made of steel, concrete, or timber, but nowadays, it is reinforced concrete. Okay? So we have here pile cap, then column. Sometimes, in other structures, you have pile, then here is mat foundation, then column. So function of pile, to transmit a foundation load to solid ground, to resist vertical lateral earth uplift load. So these are the advantage. Of course, the disadvantage, it will be difficult to transport. So there are two major categories, the end bearing and friction. Okay? So end bearing, if the depth of the rock surface or the, let's say, bedrock is reasonable to touch, we can use end bearing. But if you use piles and it will be, let's say, it is like the hard part of the soil is very difficult to attain or located at a very deep location, you need to put up a friction pile. So a friction pile, compared with this one, you touch here, the end pile is the one that will touch the hard part, which will support the wood structure. This one, it's not the end, but it's the side, or it's the perimeter or the circumference of this one. So there is a spike here, and it will create friction, skin friction between the pile and the soil, whether it is sand or clay. So this is the presentation. So pile cap, see, the location is here. So it will be uneconomical to touch that one. So you need to put the friction pile. End bearing, because here the bedrock or the firm soil stratum is located below only.